Good day, my name is Nwanda Koyana and I'm presenting my report for the D885 road upgrade. And my name is Nwanda Koyana and my student number is 19631502. Introduction. This project focuses on the upgrade of the road D885, which is 3.74 kilometers gravel road located at the Limpopo province, and it's between the change 44,400 to 48.140 kilometers. The roads currently serves more than 20 rural communities, agricultural areas, mining operation, and small-scale businesses. Due to the increased traffic and poor gravel performance, especially the rainy seasons, the road experienced routing, it experienced erosion, and also experienced the poor accessibility. Upgrading the road will significantly improve the mobility, the safety, and economic development. The purpose of the project, the main objective are as follows: is to provide a fully engineering paved and also two-lane road with improved geometric pavement and drainage standards. It will reduce the travel time. It will improve the vehicle safety. It also creates all the weather accessibilities, right? And it supports the growth economic activities such as farming, such as mining, and also moving on to align with the municipality development, improve the access to schools, clinics, and also the labor markets for the surrounding communities. Moving on to the approach and methodology. The first one is a topographical surveying, which is conducted by the surveyors using the GPS, using the DTM modeling, and the aerial photography, and it's provided the accurate alignment data and identified the existing services. Moving on, we have also the next one is the geotechnical investigation, where test pits were taken, and also maximum dry density CPR text performance along the center line, and the subgrade CPR determined to be 8%, indicating the weak soil conditions required imported material. And also the operational health and safety, whereby an agent will ensure the compliance of the what do you call this act, the Act 85 of 1993, and construction regulation, which was established in 2004. The standard that I used was to design was so big to meet the sundial, to use also the COLT 0 and also TRH, and the geometric design guidelines for the whole project, and also the design approach of the project was the initial visual inspections, which is the poor drainage, the extensive ruts, and also the weak shoulder, and moving on to the narrow cross sections. And the design tool that I used was this 3D for horizontal and also vertical alignment. I also used the TRH4 for pavement design, and the Manning's equipment for the drainage. Geometric design summary. That's when I look at the road classification, which is two-way paved road, which is 7.0 meter carriageway, and also 1.5 shoulders each side, and the total width of 10 kilometers, and the design for speed was 18 kilometers per hour, and the vertical alignment was to use the crest and also the sec, which is the minimal K values, which is the crest of 35, and the sec, which is 26, and the maximum grade was used to 88%, and the minimum grade was 0.5%. For the horizontal alignment, I used a minimum horizontal radius of 230 meters, and also the total elevation was up to 6%. And the cross section of my project was to use the 2% of crossfall and also the side drainage, and also the side drainage of both sides. Right, moving on to the onto the traffic analysis. Traffic analysis, it was given to be 375, and then use the 5% of another code and the 4.5 million, which is the road must make sure that the road does accommodates the increased traffic from the new shopping center and the farming logistics and also the farming transport. Pavement's design was to use the subgrade, which is the CPR, also of using the CPR of 8%, and they classified as the G6. The material availability as follows: it's a local G5 gravel availability, which is available, and also the crushed stone of G1 stroke G2 available, and also moving on to the asphalt concrete used for surveying. And the alternative, the first one, was used because it was chosen the best for performance and it is so cost effectively. And my final design for the project was to the design rainfall that I used was the 750 millimeters hours, and I also 10 years 20 minutes duration, and also the surface drainage that I used was the trapezoidal side drains, which is 1 meter bottom width and 0.5 meter depth, and the crossfall of 2%. And moving on to the cross-section structure, the culverts. I've used like 3 culverts in the project. The first one is in drainage 1 plus 200, which is 900 meters diameter, which is a stream crossing, and also the second one is drainage 2 plus 0.0 drainage 2 plus 800, which is 600 millimeter diameter pipe, which is used for farm drainage at the farm. And also the last one is a drainage 3 plus 400, which is the large one, which is a major channel, that one, and it has the 1200 diameter pipe. The earthworks that I use, the principle that I use for designing was the balance, the cut and fill, and also had to maintain the slope stability of my project, and also to reduce the environmental impacts. And the side slope that I used was the soil cast, which is 1:1.5, and the fill, which is 1:2, and also the rock, which is 1:0.5. The mass hole diagram ensures efficient material movement, and it's also reduced the cost. Moving on to the quality control of my project, I made sure that the compaction testing of all layers of the road and also the silvery had to be verified, and also to make sure that the culverts and also the drainage inspection have been inspected frequently, maybe I'll say frequently, quarterly possibly, and also to make sure that it complies with the CO, LTO and Sandal standards. The environmental and social impact considerations, to minimize, firstly I just need to minimize the vegetation removal. I must make sure that the vegetation is not removed unnecessary, and also to control the erosion when most of the time in construction, road construction, or farming construction, or the construction that does exist. Make sure and also manage the storm water to protect the streams that we're having in Limpopo, and also to make sure that to enhance the rural accessibility and economic opportunities, and lastly to have a job, people, to create jobs for people using the EPWP labor method, or labor intensive method. Challenges and that I encountered when I was doing the project, and also the solutions was to the first one that I encountered. I find it difficult to establish the changes that we were given in the brief of the project, since it was talking about the 44.400 kilometers and up to 48.140 kilometers, but the point file were given, but they did not show the information, so I could not populate the information. But since I was given a start and end of the road, the gravel road, that's when it assisted me. And secondly, the survey points that I was giving, the surveyor did the points, yes, but now it swapped the X and Y around, and some notifications were wrong. Sensations were wrong, so I had to figure it out by Google to find the coordinates, and that's showed for Limpopo province. So that's usually X is like 225,000 coordinates, and also the Y normally is around 4,000 coordinates. And the solutions and accommodation, the upgrades of the road, the service of the gravel road was very feasible, and it was economical friendly, also economical beneficially, and the designer had to make sure that it's improved the safety and mobility, and also to have a stronger link between the rural communities and economic hubs, and also to reduce the transport and vehicle costs, of which is going to happen. It's going to happen. And also to support the future development, such as the agriculture, such as mining, and also the shopping center. Thank you.